Good afternoon. Today we will discuss the emerging scientific discipline of applied organizational physics. It is a relatively young field of study. It was discovered shortly after the first human being attempted to get something done inside of a large organization. The theory was developed in English because everything sounds more credible in English. Let us begin with a simple model. Here we have a two-dimensional model. The first axis is correctness, thinking we are right or thinking we are wrong. That's subjective. You may associate it with your truth. The second axis is acceptance. Is your truth being accepted by someone else? So everybody, of course, believes they are correct. Otherwise, they would change their opinion. Therefore, every employee naturally places themselves in one of the two quadrants, 1 or 2. This is what we will call virtual reality for a reason that we explain in the next slide. Here we are. We call it virtual reality because organizations, they are the objective reality. They judge on acceptance of your idea or your thesis or your project. And that's why we call them objective reality. So for organizations, the important question is not who is correct. The important question is whose idea gets accepted. So that's why we call it objective reality. As you can see, there is some overlap between the two. In the scientific literature, this overlap is known as an organizational tension field. In everyday language, we may call it well, a meeting or a discussion. Let's investigate the model further. We will go back to the 4 quadrants. Quadrant 2 is, well, you are correct, and that's accepted. These individuals are often managers or, well, efficient and credible employees. Sometimes we also refer to them as visionary leaders. Occasionally, they are the people who are being asked to prepare the PowerPoint. Quadrant 1 is interesting. You're correct, but it's not being accepted. Surprisingly, this quadrant appears to be larger than most managers assume. It's actually the natural habitat of the phrase, well, you know, I told you this last year. So when people say that in a meeting, you may safely assume that they belong to quadrant 1. Quadrant 3 is an interesting one. You're wrong, and you know it. But somehow your idea is accepted and moves forward. The scientific community continues to study this phenomenon. It's quite special. Quadrant 4, well, that's a marginal quadrant, perhaps. I would say that's linked in. All right, you're wrong, and it's not accepted anyway. All right. The natural progression then. How do you move between quadrants? There's actually only one interesting move that comes to mind, and it's moving from quadrant 1. You're right, but your ideas are not getting accepted. So you want to move to quadrant 2. Where your idea, expertise, motivation come along with it, will be accepted. The way that most people think this works is by applying a force that will move the organization forward along your intended trajectory. Now, that sounds logical, but physics teaches us that logic is actually not sufficient. So what physics, classical physics, Newton's third law, for every action, for every force, there will be an equal and opposite reaction. In organizations, this is often observed as, you know, for every proposal, there will be a counter proposal, ensuring that neither proposal is implemented. For example, you might say we need to accelerate digital transformation in this or that business domain. And then the response will probably be something like, that's very interesting. I suggest that we first explore the possibilities. So that it's a standstill, temporary or for a longer period. Another example might be that you say, look guys, we need faster decision making on this. The response will probably be something like, yeah, we agree, but let's establish a committee to investigate that. We cannot change the rules and the procedures just because your idea is so interesting. So I would say Newton was right. At this point, and here we really come to the core of the organizational physics theory, we need to make an important distinction. Force is not the same thing as energy. In applied organizational physics, a force is defined just like in classical physics. A force, how do we measure it? Well, we have a certain mass. Mass is a measure for inertia, and we need to give that mass some acceleration. Instead of standing still, something needs to move at 1 meter per second or more or faster, depends on your scale. So translating that to the practice of organizations, we might say a force will be the amount of persuasive effort required to change a stakeholder's mind. It's just one example. We might have other practical or empirical definitions. We need to measure that, of course, in scientific management. So we need to redefine in Newton a little bit. So we might say it's the organizational force required to escalate an issue to the next management level, just as an example. Now, energy or work, as it's referred to in physics, and also in organizations, work, has an entirely different definition. It's a force over a distance. So force is measured in Newton, distance is measured in meter, and so we have the measure of energy as the Joule, the Newton meter. You just need to look at the energy bill of your house or to understand what it means and that it has a price and therefore is valuable. So the organizational version that I like, there are a few versions around, might be that the force that we need to apply, as in the previous example, might be a persuasion force. And for the distance, well, in meters, let's apply, psychological or political distance. Political distance is probably a good global catch-all term to measure distance in the context of organizational energy. So another example is that, again, the equivalent of the Joule might be the amount of energy required to obtain approval for a correct decision one management level higher. So not only bring it there, but also actually get it approved. The contrast, you will say, okay, what is it about? It's a very important distinction, because many people, they apply substantial force. They push and push and push, and yeah, often some of them at least perform very little useful work because they're barking up the wrong tree, for example, right? Let's give a practical example of that. So we have a mountain or a tree, something that doesn't move. It might be governance or strategic priorities. Your idea doesn't fit in them, so they can't approve it. It might be procedures or forms. Might be some manager who's vehemently opposed to the idea. So many people really attempt to move through these obstacles, and that requires considerable force, but it will often produce very little movement. The result is, many meetings, very significant force expenditure, but zero progress, zero useful work. So I put a few more examples here. Said we already had that. An approval, one management level higher, is useful energy. The energy that's required to move a stakeholder from, okay, I'm interested, to, yeah, I really agree, I will support your idea, and document that, please. or far less ambitious, the energy that's required to get, your PowerPoint slides circulating and being actually read. We're working on empirical studies. From my experience, I would say 1 euro corresponds approximately to 3 meetings. 1 or 2 of them will hopefully be useful. Or perhaps 1 well-placed sponsor. That's something for a next presentation. Sometimes you might direct your energy to a lever that multiplies your energy. So chatting with the CEO about your idea, and he confirming he thinks it's a good idea, that might set in motion a lot of energy that would otherwise require you to push alone. So let's continue. The slides might be a bit boring because we have some formulas here, but again, that's scientific management. We have energy. We said energy, work, that's useful. We also have the concept of momentum. Momentum is interesting. It's mass times velocity. Very large projects, for instance, we know that mass is a measure for inertia. So in the context of an organization, it's organizational inertia. So large projects have that. At the same time, they are moving or they are not moving. And then you need very significant momentum to initiate motion, to change basically the state of motion of your project. It might also be sort of that the program should be stopped, doesn't make sense anymore. Then you will also need a lot of momentum to actually cancel, redirect the project. So momentum tends also to resist, a change in its state of motion. So that's quite important that you realize that, because sometimes it might be just as important to stop something as to get something moving. Okay, now we come really to the what I call the ultimate concept in organizational physics, and it's also the ultimate concept in plane physics, especially in quantum mechanics, physical action. I put a lot of formulas there. Physical action is actually the product of a force over some distance during some time. And it's linked to an optimization procedure in physics that determines what is the least action path, as it's called. That might not be a linear path, not be the shortest path in terms of time or distance, but it will minimize the amount of energy that you need to expend along that path to get from point A to point B. So I put the formulas here, you can look them up, they're correct. There's another way I use here an optimization over a time path. It could also be a distance path in case we will have a momentum function as an optimization function. But here I do it energy times, infinitely small units of time measured along a certain path. And then I said we will choose the path for which the action, the physical action is minimized. SI units of measurements are there. I note there again that, you can measure it in 2 ways. Momentum over some distance or energy during a certain time interval. The 2 units are really equivalent. And it's the ultimate concept because you want to minimize energy. In many situations, that's very simple. But in complicated situations, if you have to get from point A to point B, you will want to minimize the physical action that is being expended along that path. I give an example here. I asked an AI, ChatGPT in particular, to calculate an optimal path between the starting point A and the goal, point B. I gave it a number of barriers, which we described, hierarchical barriers, processes, procedures, budget constraints, organizational silos that still might need to give approval, unclear mandates within those silos of around political sensitivity, competing priorities, that kind of stuff. So it did not do a good job. The model, I think, is theoretically correct, but the practical calculations were apparently impossible for the AI to solve. And so we see not a path from A to B, but a path from A, basically hitting, going straight into the wall, which might be a sink or a source, and in a tensor field, an organizational tensor field. And then, you know, some new paths emerged, maybe an idea that was smuggled between, you know, 2 points. And I will come to that. That's possible in quantum physics, sort of a tunneling phenomenon. But you can see it was not, the theory was practically unusable. So that's a phenomenon, I think, that's also frequently observed in organizations. We may want to move from point A to B, but we can't really establish a great roadmap. So we therefore authorized the AI to apply some more advanced techniques. And here we come here. This is sort of more of an infographic. We go from classical paths that get stuck to quantum tunneling solutions. So that's quantum organizational physics. So the difference is really what, you know, the differences between classical physics and quantum physics is normally, you know, organizational equivalent. An employee or a particle cannot pass through an obstacle, a potential barrier, or in this case, an organizational obstacle. However, in quantum physics and also in quantum organizational physics, there is a non-zero probability that might actually occur, especially if you have a dynamic understanding of the fields and the tensor fields that are actually there, invisible, but they are there. So that non-zero probability in quantum physics is quantum tunneling. There's a temporary opening. Dynamic fields change, and so at one point in time, at one point in space, suddenly a potential barrier might be not a static barrier, but sort of moving holes in the wall, and the particle can get through. In quantum organizational physics, we observe that phenomenon as well. I will give two examples. An employee sends an email and he receives an immediate enthusiastic reply. That is theoretically possible. It may not be observed a lot experimentally, but it is theoretically possible, and it is experimentally, at least in some cases, I mean, also in my experience, sometimes it happens. Another example might be a budget request. We all know that budget requests have to go through several levels of approval. People need to look at it. You need to make a cost-benefit analysis, etc., etc. So that's sometimes an obstacle, which requires a lot of energy to tunnel through. But sometimes a budget request is approved during the very first meeting. Especially when you can apply what I said, levers, use your energy at a higher level to unblock something. So that's likewise considered a quantum mechanical phenomenon, both in, well, here in quantum organizational physics. But the key conclusion remains the same. The optimal path for your idea, your proposal, your change management project, to go from point A to B, to unfreeze and refreeze, or whatever methodology you apply, the optimal path will rarely be the shortest path, neither in time nor in distance. It will sort of zigzag around, but it will get you there. So I give you here all the equations. You can dig into them. I would be curious for your observations. You can put them in the chat section or the comment section to this video, and then just let me know if that sort of corresponds to what you experience or not at all. We're almost at the end of our lecture, at 20 minutes. I will take 5 minutes more to be self-critical and re-examine really the foundation of organizational physics, which is that, you know, quadrant analysis, being correct, being not correct, and getting acceptance or not for your idea. I also put the other visual there that leads to force, but you need to make sure that the force is part of a well-directed energy, and you need to take into account, these optimizations, ensure that there's sufficient momentum to tunnel through, and don't waste time on obstacles that won't move. Now, the criticism. After many years of field research, personally, but also what I hear from other colleagues, we do see, and we have to arrive at a sort of a remarkable conclusion. I'm going to put that there, namely the idea that people want their ideas to be accepted appears to be very reasonable, but it's not entirely correct. Not everyone wants to be right. Not everyone wants to be successful. In fact, we observe that many people simply want to avoid becoming responsible for implementation. To put it bluntly, we do see lazy people in organizations, and so they will play another kind of game. The implication basically is that our original two-dimensional model is probably no longer sufficient. We need to introduce a third dimension, and that third dimension is, do we want to do that, or do we not want to do that, or do we want to delegate it? So that third dimension suddenly brings another optimization state, which may be, I am correct, I got my idea accepted, but I would like it to be implemented by somebody else. This phenomenon, this optimization behavior is commonly referred to as leadership, or, depending on the job title, strategic management. In a 3D model where you have that other axis of, who's going to actually do the job, we have then 8 quadrants, not 4. We have a very interesting quadrant where, I'm correct, my idea is not accepted, and there's no implementation responsibility. So nothing is happening with that, but some people are content with that. I'm right, I have an idea, it didn't get accepted by the organization, and as a result, I have no implementation responsibility. This group actually consistently scores very high levels of subjective satisfaction about the situation. So let us conclude this first lecture on applied organizational physics by repeating the key messages. Not everything that moves goes forward. It may go round and round. Not everything that moves is therefore making real progress. Now, not everything that makes progress should be your idea. The idea might come from others. That also, you should be humble and sometimes just walk along and expend energy on ideas that maybe you don't agree to, but that move forward and are being considered as accepted. Because finally, and this is the most important thing, your belief that you are correct or not correct, that belongs to the realm of virtual reality. And you belong to an organization which belongs to the realm of objective reality. So that's an important message. Also, if things go wrong, that's more a personal thing, not directly, I can't derive it directly from the model as an axiom, but not everything that doesn't work, some things fail. We live in a world that is what I call statistically deterministic. So even if we optimize, we have a roadmap with the quantum tunnels and everything, it might happen that, we can't know full reality and something goes wrong. Such failures are not necessarily your fault. So that's then actually the research implication where we want to go actually. We realize that this original two-dimensional model isn't sufficient. We must transition to three-dimensional modeling, which is complex in physics and will be equally complex in organizational physics. But it should work. I said classical physics studies the motion of matter through space. So we study the motion of ideas through organizations. The equations work and are pretty similar. So it will make the equations much harder, but I think that might be a reason why management consultants will be quite and are so enthusiastic about it. I thank you for your attention, and I will see you at the next introductory lectures to organizational physics. Thank you very much. Have a nice day.